Hi my friend, welcome to All About Emerald course. This course is about emerald gemstone, how to identify, how to grade, how to buy, and finally how to carry it. Generally this course doesn't need to any prerequisite, but if you take the other my course as fundamental of gemology, you will learn better. But don't worry, this course will teach you all things you need. So let's go to the course. This lecture will teach you basic and fundamental information about emeralds. Generally, this course are applicable especially when you want to identify in laboratory. This information no need to remember because they are existing in gemology books, but in my opinion, it will be useful to remember some basic information such as crystal structures, crystal habit, appearance, hardness, because knowing those information will help you to identify emerald quickly. The beryls are among the most popular and also the most expensive of all gems. A wide range of color is represented from colorless to black. Emerald is most famous green color member of beryl group, which is colored by chromium or vanadium. In emerald chemical composition, following items are included: beryllium, aluminum, silicon, oxygen, chromium, and or vanadium. Aquamarine is another variety of beryl group that is same in crystal structure with emerald, but is different in color due to the presence of iron in chemical structure or chemical composition. In fact, aquamarine's chemical composition have similar items like emerald except vanadium or chrome. Because in aquamarine, vanadium or chrome are replaced with iron. This replacing lead to change in color of emerald to blue. So you see the aquamarine as blue color. Heliodor is another member of beryl group that is not too common like emerald or aquamarine. This variety of beryl group seems pale yellow to deep yellowish orange due to presence of ferric iron. The strength of color depends on presence of ferric iron in Heliodor chemical composition. Red beryl is another rarer member of beryl group that is not too common like emerald or aquamarine. This variety of beryl group seems red, sometimes pink due to presence of ferric iron. The strength of color depends on presence of ferric iron in red beryl chemical composition. Morganite is also another member of beryl group. This variety of beryl group seems pink or salmon peachy pink color due to presence of manganese. The strength of color depends on presence of manganese in morganite chemical composition. Gushenite is another member of beryl group. This variety of beryl group is a purest member of beryl due to lack of any external item in its chemical composition. It seems colorless due to lack of any coloring agent such as chrome, vanadium, or iron. Traditionally, crystallography is the study of crystals and describing them according to geometrical observation. This involves measurement of the crystal faces in relation to their imaginary crystal axes using a goniometer and symmetry. In modern times, crystallography is the study of atoms arrangements in solid using X-ray diffraction photography. Generally, a crystal is a geometrical solid bound by flat surfaces. Has a regular and symmetrical pattern of atoms or crystal lattice. Has physical and optical properties that may vary with direction. Emerald, as a member of Brill group, has hexagonal crystal system. In the hexagonal crystal system, we have an additional axis giving the crystal six sides. Three of these are equal in length and meet at 120 degrees to each others. The C or vertical axis is at 90 degree to the horizontal axis. Mineralogists sometimes divide this into two systems, the hexagonal and the trigonal, based on their external appearance. Emerald crystal habit means the form that they are found in nature or in rough appearance. While emerald crystal structure is hexagonal, but this form of crystal structure is happen in nature in different forms, such as flat hexagonal crystal, elongated hexagonal crystal, or curved hexagonal crystal. You can see those forms in these pictures. In this picture you can see a sample of Afghanistan emerald that shapes that its shape is in an elongated hexagonal crystal. This is another sample of Afghanistan emerald. And also this is another sample. This is a Colombian emerald that you can see the hexagonal crystal system perfectly. This is a big size of Zambian emerald with hexagonal crystal system. Another basic information of emerald is hardness. Hardness of emerald is one of the most important of emerald identity that turn it to gem. Because you know that gems are those stones that have durability, beauty, and rarity specification. In emerald, durability comes from hardness and toughness. As you can see in the graph, the hardness of emerald drops between 8 and 7. That is good hardness for daily using of emerald as jewelry. Beside the hardness, the toughness of emerald is also fair and good, but not too good. Another physical properties of gemstone that is specific gravity which is also known as the relative density. It means that a number which is defined as the ratio between the weight of a stone in the air and the weight of a stone and the weight of an equal volume in water. Since specific gravity is relative to the weight of an object in air and its weight in water, it is a ratio and is not expressed in unit such as kilogram per cubic meter. The specific gravity of emerald is about 2.68 to 2.78. Cleavage is the splitting of a gemstone along the direction of its crystal faces, where atoms have weaker bonding. This can occur only in crystalline minerals when a precise blow is given in a particular direction. The result of cleavage is a more or less flat plane with often a silky luster. Cleavage is a reproducible property of a gemstone and can be done at any point of the cleavage direction. Emerald mostly has one direction of imperfect cleavage. Okay, my friend, this lecture is finished, and now we know the basic information about emerald that are useful when we want to identify emerald. In next lecture we will discuss about main producers of emerald in the world. See you in next lecture.